Alright, so we're going to look at section 2, exercises 1 through 20 for some examples of how to work with our exponentials or exponents in our expressions here. So what we'll do is we'll parallel some of the ones going through. So we'll look at number 2 first. Let's see if I can. There we go. So number 2, we want 5 to the third. Well, by definition, taking something to a third power is multiplying 5 by 5 by 5, which is 25 times 5, or 125. And let's add some sign issues into it. So we'll look at 6. -7 squared. Now, to avoid ambiguity, there's no parentheses here. So this is saying we want -7 times 7. So we take 7 times 7, we get 49, and we keep the negative sign out front. We compare that to number 4, where we add the grouping symbols of the parentheses. This is saying we're having -4 times -4. Well, a negative times a negative is positive, so that gives us 16. I think a good key here is how these parentheses interact differently with our exponents. If there are no parentheses, that negative sign is hanging out front and it doesn't get multiplied twice. But by adding that grouping symbol, we specifically say that we want that negative sign multiplied across. All right, scroll up. Let's look at some of the other ones. So we will look at 10. So we have -8x to the 0. Now, this exponent has no parentheses, so it's only attached to the x. Well, anything to the 0 power is 1, so this is -8 times 1, or just plain old -8. 12, a to the -1, uses our property that the negative sign pulls the variable underneath the fraction bar, or to the other side of the fraction bar. If it goes downstairs, it would come upstairs. It's upstairs, it goes downstairs. So a to the -1, by definition, is 1 over a. We'll also say, hey, a can't be 0. We're not going to be able to divide by 0 here. Well, we can use that with some specific numbers here. So 3 to the -4 is the same as 1 over 3 to the 4th, or 1 over 3 times 3 times 3 times 3. Is that 4 of them? Yeah, we got 4 of them there. And I'll just do these in pairs. These 3's is not become 9. These 3's become 9, or we get 1 over 81, which is a pretty small number. And exponentials with negative signs have a tendency to decrease. So this is what these are not exponentials, I'm sorry, exponents with negative signs. Exponentials are different things. And that's when your variable is upstairs like that, but we will get to those in a bit. Well, we can look at 20, the last one in this set, which combines a lot of our properties. 6 times 4 squared times 4 minus 4, or 4 to the -4. I'll be very clear here. A bit late at night. I'm stumbling around word-wise, but I'll fix it. Notice these have the same base. So we can say 4 minus 4. We can add these exponents using our rules of exponents, but 6 is going to hang out there still. 2 minus 4 is the negative second. You're saying that's the same as bringing it downstairs. So that becomes 6 over 4 squared. Well, that's the same as 6 over 16. But notice, both of these are divisible by 2. 2 times 3, 2 times 8. Anything over itself is 1. And we get 3/8. And this is how we use exponents and how the rules of exponents are used in these expressions. And we'll look at some more examples as we progress here and work our way through section 2.